Okay, so this is part 4 of our lesson on graphing exponential functions. And in this lesson, we're going to look at an exponential function where the base is e. All right, now remember e in part 1, we talked about the base e in part 1, the number e in part 1. So remember, go back to part 1 and look at the lesson. But e, remember, is an irrational number. And e is approximately equal to 2.718. So it's an irrational number. It does not terminate. There are no repetition of digits, okay? But we do approximate it to that, but we are going to use our calculator's e. So we looked in part 1 how to use our calculator, the function e to the x right here in part 1. So it's important that you remember how to do that. Okay, so one of the things I need to remind you, though, let's kind of review something from part 3 in terms of what the graphs do with certain bases. All right, so in part 3, I'm looking at part 3. What I want you to remember in part 3 is this. So you see how the base was 1/4? And we talked about the fact that if the base is a proper fraction, so if b, and let me go ahead and do that on another sheet of paper. So if I have my function, my exponential function f of x equal b to the x, if the base is a proper fraction, okay, and there's no negative out in front, then this is going to be a decreasing function. So remember, we talked about the fact that the y values get smaller and smaller and smaller and smaller, and it flattens out to the right side. Okay, so it rises on the left, flattens out on the right. Now remember, it really doesn't flatten out because the y values are still getting smaller. Well, they're getting larger to the horizontal asymptote. All right, but it's at a slower pace. Okay. Okay, so if b is a proper fraction, the graph does something like this, right? Okay. We saw that if b is an improper fraction, okay, an improper fraction, where b is greater than 1, let's say, it cannot equal 1, so that's why I'm not putting equal 1, because remember, the base can be 1, cannot be 1. So when we looked at that, we saw something like this. So in this example, if I can find it real quick, like 3/2, y equals 3/2 to the x power, so 3/2 is 1.5. And so notice that this is an increasing function. So as my x values get bigger, my y values increase. So with an increasing function, it levels out, it flattens out on the left side and rises rapidly on the right side. Okay, so if b is an improper fraction, we get a graph that looks like this. All right. Okay. Now, the other thing I want to show you is this. So the question is, we keep talking about why b cannot be 1. All right. Well, let's look at that. All right. So you know what the shape of an exponential function looks like. But if suppose b was 1, suppose b equals 1. All right. So if b is 1, we get y equals 1 to the x power, right? And if I look at that, so if I let x be 0, what's 1 to the 0? Okay, 1. What if I let x be 2? What's 1 to the second power? 1. If I let x be 4, what's 1 to the fourth power? 1. Do you see that basically no matter what x is, my y value is going to be 1? And notice this is a linear equation, not an exponential. And so when I look at the graph, remember what the graph looks like. If this is y equal 1, this is the graph of that equation. Does that look like an exponential function? No, that's a linear function. Okay, so this is a linear function. So that's why b cannot be 1, because if b was 1, you would no longer have an exponential function. You would have a linear function. Okay? All right, now let's go back to this. So basically, we're going to do the same thing we did in the past, in the previous 3 lessons, in parts 2 and 3 rather. And so we're just going to use a t-table, use a few points as possible, and then draw a graph. Because I know this. I know that this is an exponential function, and I know that f of x is equal to e to the x plus 0. So what does that 0 imply? Okay, yeah, so that 0 implies that the horizontal asymptote is y equals 0, which is the x-axis, right? So I'm going to go ahead now, and I'm just going to go ahead, and I'm going to use this graph here. I'm going to go ahead and draw a dotted line. This is the x-axis. I just went ahead and used the first and second quadrants. And I'm going to draw a dotted line. So there's my horizontal asymptote. Okay, and I know that since e is a number bigger than 1, and there's no reflection across the horizontal asymptote because there's no negative out in front. I know that since e is greater than 1, my graph is going to have to look something like this. All right. Now, remember we talked about the idea of that reflection. So in part 3, if you go back to part 3, we did a couple of problems where there were reflections across the horizontal asymptote. So here's one of them. So notice that there's negative out here. So that means that instead of the graph being above, instead of the graph doing this, it actually is a reflection about the horizontal asymptote. Okay. All right. Now, so I know that my horizontal asymptote is y equal 0, right? Okay. So using a t-table, remember we always have a y-intercept. So to find the y-intercept, you let x be 0. So I get e to the 0, right, which is 1. All right, so I found one of my points. So one of my points is 0, 1, right here. 0, 1. Okay. All right, so let x be, let's say, 1. Well, if x is 1, I get e to the first, which I know, without even using a calculator, that's 2.718. All agree? All right, so I get something that looks like this. So 2.718 is around here, close to 3, let's say. All right. If x is, let's say, 2, I get e squared. Now I'm going to use a calculator here. So e squared, remember how to get to that. So to find e squared, you're going to press your L in button right here. So you can press second though first. All right, and you see get e raised to a power. So as a second power, press close that parentheses and press equal, and you get 7 point. I'm going to go ahead and round to nearest tenth. So 7.4. It's about 7.4. And so I get 7.4, which is about, this is 7, so 7.4 about here. Okay, so I know what happens on this side, right? So what happens on this side? On this side, it flattens out. So it goes towards the horizontal asymptote to do something like this. And on this side, so that's enough points for right now. On this side, it does this. It rises rapidly. So make it look like it's rising rapidly. See how it looks? Don't all of a sudden make your graph go straight up, because it doesn't. All right, because remember, as your x values increase, your y values increase. It's got to look like it's increasing, but it's increasing exponentially. So make it look steep. All right, and if you need to plot another point, because I think there's enough numbers here up to 20. No, it's not going to work. So I was going to say if you let x be 3, you're going to get e cubed, but that is that I don't think that would be enough. Let's see, e because 3 cubed is 27, and that only goes to 20. So e is a little less than that, so I don't think it will work as well. So let's see. I'm going to go up here and just going to change the 2 to a 3, and then press equal. Yeah, well, almost 20.1. All All right, so when x is 3, you get 20.1, which is about here. So really, a better graph would have been kind of like this, but that's fine. I mean, you're just sketching the graph as best you can. Okay. All right. So that is f of x equal e to the x. All right. Now let's look at this. Let's look at suppose we had, so this is number 1. Oh, and by the way, so what's the domain? All right. So the domain is all real numbers, because remember that's an exponential. The range. Okay. So you should have enough experience now to tell me what the range is. So so the range is above the horizontal asymptote, so you're going to start at the horizontal asymptote, and that's y equal, so the horizontal asymptote is y equals 0, right? The x-axis. So you go from 0 all the way to infinity. So the range is 0 to infinity. And the y-intercept we already found. The y-intercept is 0, 1. Okay? All right, number 2. Suppose I had f of x equal e to the x minus 3, let's say. E to the x minus 3. Okay, so let's see what happens there. So I'm going to have to use a different grid because I need something further down. Okay, so e to the x minus 3. Well, do I know the horizontal asymptote? Yes, you do. What's the horizontal asymptote? Negative 3. So the horizontal asymptote is y equals negative 3. So right away, I can go and I'm going to go ahead and use this. So I can go ahead and draw my horizontal asymptote. So y equals negative 3, right? Okay, so y equals negative 3. So I get something that looks like this. So draw your horizontal asymptote, dotted line, just like that. Okay. All right. Now let's find the y-intercept. So the y-intercept, you're going to let x equals 0. So if x is 0, I get e to the 0 minus 3. E to the 0 is 1. 1 minus 3 is a negative 2, right? Okay. So there's my y-intercept, 0, negative 2. Okay. Now, you know, first of all, you see that the graph is above the horizontal asymptote, right? Because there was no negative out here, so there's no reflection about the horizontal asymptote. So, and you know that e is greater than 1, so it's an improper fraction, so you know it's going to do this, correct? Okay. So right away I know on this side it's going to do this. So I'm going to go ahead, without even plotting any points, I know that. On this side, though, I know it's going to rise. So let's just pick some points. So if x is 1, I get e to the first minus 3. Use your calculator. So e to the first. So second, ln, 1, and then minus 3 equal. So that's about negative 0.3. So that's about negative 0.3, right? So when x is 1, negative 0.3 is about here, let's say. Okay. Let x be 2. If x is so that's about negative 0.3. So I'm approximating here. When x is 2, I get e squared minus 3. Use your calculator. E squared minus 3. I'm going to go ahead and just move my arrows and get to it. So e squared minus 3, press equal. That's about 4.4. Right, 4.4. And so you're good at that point. So 4.4 to 4.4 is about here, let's say. So I get something that looks like this. All right, and so there's your graph. All right, so that's f of x equal e to the x minus 3. Okay? All right, what I want to do, though, is this. I want to look at what happens. Oh, and by the way, what's the domain? All right, so yes, the domain, same as everything else, right? Every other exponential function, all real numbers. What's the range, though? So remember, the range, you're going from the horizontal asymptote, which is y equal negative 3. Y equal negative 3. And remember, is negative 3 the smallest y value? No, it gets close to it, though, right? That's the closest it gets to. It gets closer and closer and closer to negative 3 without touching it. So we say negative 3, all the way to infinity. So y equals -3 with parentheses all the way to infinity. And we found the y-intercept and we found the horizontal asymptote. Okay? All right, I want to do this though. I want to do the same problem, but instead, let's call this g of x and say this. What's the only difference? What's the only difference between these two right here? Yeah, that right here. What does that tell you? Do you remember from the previous part? What do you think that is? So we know that this graph does this, right? What do you think this does? All right, so if you think about the part 3, that part is just a reflection about the horizontal asymptote. And you're going to see that. So let's actually do that and see what that looks like. All right, so I know still the horizontal asymptote is y equal -3. Y'all agree? All right, so I'm going to keep my horizontal asymptote as it is because it's still the same thing. It's still -3, y equal -3. All right, let's look at the y-intercept though. So that's going to be different. So the y-intercept is 0. I'm sorry, let x be 0. So I get negative e to the 0 minus 3. Remember, you do this part first. E to the 0 is 1, so this becomes a -1. And what's a -1 subtract 3? -4. All right, so I know this. I know this. So I get this now. Okay? All right, let x be 1. If x is 1, let's see what happens. I get negative e to the first power minus 3. Use your calculator. Negative e to the first. So you're going to say this. You're going to say negative right here. See, it shows up here. Second, e, and say 1, close the parentheses, minus 3 equal negative about 5.7, negative 5.7 approximately. Okay. All right, so negative 5.7. So that's about, so that was 1, 5.7 about here, right? Okay. If x is, let's say, 2, if x is 2, I get negative e squared minus 3. Okay, negative e squared minus 3. All right, you got to do this first now. Okay, so here's how you can do that. Well, you would do that first, but you're just putting things in your calculator. So let's just go ahead and use a calculator. So negative second e squared, see how that looks? And then minus 3 equal about negative 10.4. All right, so 2 negative 10.4 is about here. All right, and so even before I plotted all these other points, do you see that this part of the graph does this? And then this part of the graph does this? Okay. Now, do you see? It's important. I'm going to go ahead and make this zoom in. Okay. Do you see that so here's a horizontal asymptote. Okay. What I'm trying to get you to think about is this. Do you see? Do you see that the distance from this point right here, to the horizontal asymptote, so that distance is the same as this? See how it looks? Because it's symmetrical. It's symmetrical about that horizontal asymptote. So this point is reflected about the horizontal asymptote. That point right here, that point is reflected about the horizontal asymptote. So that distance here from your, and here's the horizontal asymptote, so that distance from here to here is the same as the horizontal asymptote to here. You see that? All right, same thing here. So see how those distances are the same. So that's the idea that's symmetrical about the horizontal asymptote. Okay, so that was the graph g of x equal negative e to the x minus 3. All right, so I think that should be good enough from parts 2 and 3 and this part for you to do the worksheet dealing with base e. Okay, so that's going to take care of part 4. All right, part 4.